Does light have weight, and if not, what does this mean for its energy? Hello everyone, and welcome back to our YouTube channel. Today, we will be discussing an interesting topic that has been debated among physicists for decades. We will dive into the world of light and explore whether it has mass and energy. The question is, does light have weight, and if not, what does this mean for its energy? Before we delve into the nitty-gritty of light, we need to take a trip back in time to 1905, when Albert Einstein published his theory of relativity. In this theory, he stated that energy and mass are interchangeable, and the famous equation E equals mc squared was born. This equation shows that an object's energy is equivalent to its mass, multiplied by the speed of light squared. If we apply this equation to light, we will find that its energy should be equivalent to its mass, which raises the question of whether light actually has mass. Well, according to Einstein's theory of relativity, light, or electromagnetic radiation, does not have mass. This theory is supported by many experiments that have been conducted over the years. Firstly, let's take a look at the famous Michelson-Morley experiment, which was conducted in 1887 to measure the speed of light. This experiment showed that the speed of light is constant regardless of the motion of the observer or the source of the light. If light had mass, its speed would change depending on the motion of the observer or the source, which was not observed during the experiment. Another important experiment that supports Einstein's theory is the Compton scattering experiment. This showed that when light interacts with matter, it behaves like a wave with a certain frequency but no mass. Therefore, we can safely say that light does not have mass. But if light doesn't have mass, does it mean that it also has no energy? The answer to this question is, interestingly, no. Light has energy because it can cause matter to move. This energy is known as electromagnetic energy. Electromagnetic energy is a type of energy that travels in waves, and it is present in almost everything around us. Radio waves, microwaves, infrared waves, visible light, ultraviolet waves, X-rays, and gamma rays are all forms of electromagnetic energy. Each wave of electromagnetic energy carries a certain amount of energy, which is directly proportional to its frequency. The higher the frequency of the wave, the greater the energy it carries. This means that gamma rays carry the most energy, followed by X-rays, ultraviolet radiation, visible light, infrared radiation, microwaves, and radio waves. So, how does electromagnetic energy interact with matter? When electromagnetic energy is absorbed by matter, it causes the atoms and molecules within that matter to vibrate, which, in turn, increases the temperature of that matter. This is why electromagnetic energy is also referred to as radiant energy. Moreover, electromagnetic energy can also cause chemical reactions to occur, such as those that occur in photosynthesis when the energy from the sun is absorbed by plants. In this way, electromagnetic energy is crucial for the survival of all living organisms. In conclusion, light does not have mass, but it does have energy. This energy is known as electromagnetic energy and is present in many different forms. The theory of relativity proposed by Einstein gave us an insight into the mass-energy equivalence, and its application paved the way for the development of many technological advancements in the field of physics. Thank you for tuning into our channel today. If you have any questions, leave them in the comments section below, and we'll do our best to answer them. Don't forget to like and subscribe for more interesting content, and we'll see you in the next video. Thanks for watching.